to start with section 1.1, and our learning objectives for section 1.1 are going to be to construct and interpret bar graphs and pie charts, recognize good and bad graphs, construct and interpret two-way tables, and describe relationships between two categorical variables, and organize statistical problems. So we're going to get some vocabulary words here. Categorical versus quantitative. And you guys are going to be using these two words all throughout the course. You really need to know the difference. So categorical, you could also call it qualitative. And here it's not going to be where you're counting. It's going to be more like you could have categories of data. So observations fall into separate or distinct categories. So there's two types of categories, nominal and ordinal. And with the nominal, I think of it as right here with the no in front. So it means there's no order. So eye color, hair color, none of these have an order. There's no particular rank. One is better than the other. But when you do have ordinal, and again here it kind of starts with ORD order, so you do have an order. So letter grades, an A, B, C, D, or F. Socioeconomical status, job levels. So you can have those ranked in a particular order of like moving up, so one being better than the other. So that is categorical when you have categories and you have those two types. Now quantitative, you're going to be here with numbers. It's measurable or countable. So this is really important. It's going to be measurable or countable. So think quantities. Okay, so quantities, quantitative data. And again, you're going to have two different types of quantitative data. You have discrete. So in discrete, values correspond to isolated points on a number line. So for instance, if you think of a number line, you're only going to hit certain values. So you may hit here, 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 whatever, but you're only going to have certain values. So example, the number of people in a house. Well, that's not continuous. You could have 1 or 2, but you can't have 1.1. Okay, so you're not going to hit every single data. So shoe size, you could have a 7, a 7.5, an 8, an 8.5. So these are discrete values. Now, really common misconception with discrete is people think it has to be integers, and that's not correct. So while you can have integers, you don't even have to have integer values. So here it just means only certain values, whereas continuous are going to be on an entire interval or number line. So if you think about the weight of a baby, let's say the minimum weight would be like 1 pound, and you could go all the way until, this would be horrible to give birth, but let's just say like a 30 pounds, probably in the Guinness Book of World Record or something. But it means that you could hit every single thing between 1 to 30. So that's continuous. There's an infinite amount in between there. Same thing for the height of a tree. So you could start at height like 0 and go all the way up to, I don't know, whatever the biggest tree in the world is. But you can have every single value in between those two. So that's continuous. So look over these. I want you to classify the following as qualitative or quantitative, and remember that quantitative just means categorical. For those that are qualitative, determine if they are ordinal or nominal, and for those that are quantitative, see if they are discrete or continuous. So go ahead and pause me now, look through these, and see if you cannot find what they would be. All right, now that you've unpaused me, I'm going to give you a second chance to pause. Okay, now that you've unpaused me, I'm going to go over the answers with you. So the number of students in a class of 35 who turn in a term paper. Well, this is countable. So if you can count, then it's going to be quantitative. And since the number of students, you can't have a fraction of a student going on. You could only have certain. So you could have 0 students, 1 student, all the way up to 35 students. So this would be discrete. You're not going to hit every single value between 0 to 35. You're only, in this case, hitting the integers. Amount of fluid in ounces dispensed by a machine to fill bottles of soda pop. Well, this is quantitative again because it's countable, but in this case, it is continuous. You could have 0 ounces, you could have 0.1111 ounces, you have 0.121314, I don't know, I'm just making up something, ounces, all the way to, let's say, it's a 35 ounce or 32 ounce bottle. So you could have from 0 all the way to like 32 ounces and everything in between. So this would be continuous. Birth order classification. So in this case, this would be categorical because you can't count birth order. These are categories. So if you're a first child, middle child, last child, but you can't put them in order. So this is ordinal. State of birth for someone born in the United States. So this is categorical. Now, you could say, oh, there's really no particular order to the states, or you could say, I could alphabetize them and put them in order, so that's ordinal. I could say when the states were added to our nation, so as they're added, you could say, I'm going to put the order that way. So if you say that there's no order because states don't really have a general order, you could really go for nominal, but I would say the best case scenario, I would say ordinal, because you could put states in a certain order. Okay, price of a textbook. This is quantitative. However, this is discrete because money only goes to 2 decimal places. So like if it was $55, 55.01, 55.02, so you would not hit 55.001. That could not be a textbook price because with money you only go to 2 decimals. So this is still discrete even though it's not integer values. So 6, concentration of contaminants in a water sample. So this is again quantitative and it is continuous. Zip code, categorical, and this is kind of like the states. I could say you could put a numerical order for zip codes, so or you could put an order from West Coast to East Coast, whatever. But I would definitely say ordinal here because you could put them in order. But zip codes are categorical. You're not counting up the zip codes, even though it deals with numbers. It's still a category. 8, the actual weight of coffee in a 1-pound can. So this is quantitative. You are counting it, and it's continuous. And 9, the number of insufficient funds checks received by a grocery store. So again, you're counting. This is quantitative. However, this would be discrete. You could only have a set number of insufficient funds. You couldn't have 1.1 as a number of the checks. All right, so when you're graphing things, you have to remember, label everything. So label, and give an overall label. Okay, so make sure you are labeling everything. Cumulative frequency should always total how many data you have. So if you're accumulating things at the very end, that should be your overall total. Cumulative relative frequency should always give you 100%, unless you're doing a round-off error. If you round relative frequencies, then sometimes the cumulative relative frequency could add up to like 99%. So it just kind of depends on how you rounded, but if you didn't round, it would always be 100%. All right, so categorical variables. Let's deal with those first. So here you could have the categorical variable, and then you could have all the values in the category. So here it looks like my variable is format, and then these are all the different things that fall under format. And here it says these over here are just the counts. That's how many you have. So how many stations are adult contemporary would be 1,556. So you could kind of go through there. And this is your overall just the counts total. So here relative frequency, that would be your percent. So if I took the amount divided by the total, and it looks like here we're going to round to 1 decimal place for everything, then this is the value you would get. Now, you can see we got a little bit of a round off error down here with this 99.9%. That's what I was kind of talking about because we rounded everything. So we have our variable, all the values, the counts. So here, if you just want to see the counts, you can go and put a bar graph. So with bar graphs, you have spaces in between the graphs because these are different categories. It's not like it's just a continuous amount going from like 0 to 1 or anything. That's not what you're doing here. You're just labeling how many you have in the category because you have categorical data. So when you have categorical data, you're going to use bar graphs. Now over here, when you have percents, you could make a pie chart, absolutely. Or you could still make a bar graph, but instead of over here with the counts, you would have percentages. So it looks like the highest percentage I would need to go up to is 16%. So you might even just go by ones, 1%, 2%, all the way up. Okay? All right, so bar graphs, they graph the frequency distribution of categorical data. So let's do another example. Portable MP3 music players, such as the Apple iPod, are popular but not equally popular with people of all ages. Here are the percents of people in various age groups who own a portable MP3 player. It's kind of outdated, right? Nobody has an MP3 player anymore. But anyway, according to a survey of 1,112 randomly selected people. All right, so within the age groups, here you can see how many own an MP3 player. Sorry if you own an MP3 player. All right, so make a well-labeled bar graph to display the data and describe what you see. Would it be appropriate to make a pie chart for this data? Why or why not? So I want you to pause this and answer these questions before we move on. Okay, now that you've unpaused, let's go over what this would look like. So here, again, this is categories. We have our different categories of age groups. And then I have the percent who own an MP3 player. So this is what we were kind of talking about before. We could label over here, we could do percents all the way up. You might give an overall MP3 player data or something like this for the overall label as well. But label, label, label. So here it appears that MP3 players are more popular among young people and that their popularity generally decreases as age category increases. All right, so part B, if you wanted to make a pie chart, it's not really appropriate because each percent in the table refers to a different age group. It's not parsed to a whole. So if you added all these up, you're going to get over 100%. So that's why you don't want to do a pie chart in this one. All right, so let's make a bar chart for the following. You can pause me, this one shouldn't take too long. And this is what I got. So I would label, and then here I might put ice cream flavors. So label, label, label. And there's my bar graph. Okay, so what if, however, I wanted to take this data and form two different groups, or strata, it's going to be a vocabulary here that we'll be dealing with in the future, by males and females. And here are my results shown below. So let's say I wanted to make a bar graph for this data. If you made it like this, that is not good. Sorry. Okay, so what's misleading about this graph? When I look at all of these, it looks like, whoa, males like chocolate better because here it's higher than females. Oh, males like vanilla better because it's higher than the females, and males like strawberry better because it's higher than the females. What is wrong? Why is this so misleading? Okay, so in this case, when we started, kind of look back here for a second, what's your total here going on for males? 12, 13, 14, 15 males total. And what's your total for females? 7. So you started with more males. So it's not really fair, since your survey wasn't equal here, just to do a side-by-side bar chart with the counts going on. So a side-by-side bar chart wouldn't be that bad, but instead of using counts, I would use relative frequencies. So now here, if you make it relative frequencies, so you put how many males like chocolate out of the total males here, and got 53%. Same thing, how many males like vanilla out of the total males, and fill in everything with males and females. Then, once you graph here using the relative frequency, so these are all in percents going on, now you can compare a little bit better. Well, definitely a lot of males like chocolate. That's okay. So, but now you can see that more of the females liked vanilla and strawberry relative to how many you had. This is a lot more appropriate. Okay, here's a little joke for you. Yeah, I love this guy. Can you just imagine, ooh, right? Because people just don't always understand what's going on, so you can just wow by putting in all these fancy charts. That's kind of fun. All right, this ad for DirecTV has multiple problems. What is wrong with what's being shown here for this ad? Let's just think through it for a second. Okay, so first off, the heights aren't that accurate. This says 95%, and look at this distance between 95 to 81, and look at this distance between 95 to 56. So they really didn't go in order of the heights very well. The second thing that would really be wrong is they made this width a lot more than the other widths. You don't want to do that. You want to make everything equal widths. So besides the heights not being correct, you shouldn't have equal widths. You should have the same widths. So if I was going to make this, so you have DirecTV, you have Dish, you could go 10, 20, 30, 40. Actually, let me go maybe by 20 so I can get there a little easier. 20, 30, 40, 60, 80, 100. So here, if I was going to make my dish at 95%, it would look something more like this going on. That was DirecTV. My dish is at 81%. So it would be something more like that. And then the 56%er, something more like that. And you want it all to be equal what's going on. All right, another example for you. Yay! When Apple Incorporated introduced the iMac, the company wanted to know whether this new computer was expanding Apple's market share. Was the iMac mainly being bought by previous Macintosh owners, or was it being purchased by first-time computer buyers and by previous PC users who were switching over? To find out, Apple hired a firm to conduct a survey of 500 iMac customers. Each customer was categorized as a new computer purchaser, a previous PC owner, or a previous Macintosh owner. The table summarizes the survey results. All right, so then they said, here's a clever graph of the data that uses pictures instead of the more traditional bars. Is this graph misleading? Why or why not? Look at this little tiny Windows little guy, right? They really made it misleading. They made it look like Macintoshes were just this fabulous big old computer that everybody wants. So they exaggerated the widths going on for each of those computers. So even though the heights are accurate, the widths are not, it looks like, with that big old computer that they wrote, that more people want the max. All right, two possible bar graphs of data are shown on the next page, or sorry, on this page. Which one could be considered deceptive and why? All right, so look over here. This one's 0, 10, 20, 30, 40, 50. This one cut off the bottoms and really just only showed the tops. So the one to the right is going to be misleading. So by starting at 10 instead of at 0, it looks like the percent of iMac buyers who previously owned a PC is less than half the percent who are first-time computer buyers. So we get a distorted impression of the relative percents of the three categories. So here you can see if you actually brought it down, they're not as far off as it made it appear. They only show the tops. All right, two-way tables and marginal distributions. When a data set involves two categorical variables, we begin by examining the counts or percents in various categories for one of the three variables. So a two-way table describes two categorical variables, organizing counts according to a row variable and a column variable. So for instance, you could have boys and girls, and you can have maybe the chocolate, the strawberry, the vanilla, and all the counts. This would be a two-way table that you would be filling in. All right, so what are the variables described by this two-way table, and how many young adults were surveyed? So your variables described would be your gender and the chance of getting rich. The total is always going to be right here. This is your overall total. Relationships between categorical variables. Marginal distributions tell us nothing about the relationship between variables. So, conditional distribution of a variable describes the values of that variable among individuals who have a specific value of another variable. Oh, right? Okay. So, in order to compare or examine conditional distributions, you're going to select the rows or columns of interest. You're going to use the data in the table to calculate the conditional distribution in percents of the rows and or columns. Make a graph to display the conditional distribution, and here you could use a side-by-side bar graph or a segmented bar graph to compare these. All right, so two-way tables and conditional distributions. Calculate the conditional distribution of opinion among males. So here we're going to do it among males. Examine the relationship between gender and the opinion of what they feel their chance of getting rich would be. All right, so here I can see that in the first one of almost no chance, there was a 98 out of just here, just the conditional, we're only taking it out of this total. So for conditional, we're just looking at the males according to their opinion of their chance of getting rich. So these guys right here would be the marginal distribution for the conditional. The conditional distribution of that. And then you can make this into a bar graph. Here, you're going to definitely put it with percents. So you can have their opinion of chance of getting rich, and then the percents, and then we label here as well. Now, it also wanted me to find, because it said between gender, so if I want to look for the females and do that conditional probability, then I can take 96 out of the total females to see the relative percent for almost no chance. So that's your conditional distribution here. Now I could put a side-by-side bar graph between males and females to kind of see what's going on. So almost no chance, they look about the same. Some chance, women feel more confident that they have some chance. A 50-50 chance, again, people feel about the same. A good chance, men are more confident, and know that they're almost certain men were more confident here. So for whatever reason in this guy, the chance of being wealthy by age 30, this was how this survey turned out. Just another way of looking at it. So you can have your segmented bar graph here. It's kind of nice to see as well. All right, now marginal distribution of one of the categorical variables in a two-way table is the distribution of values of that variable among all individuals described by the table. So here you're going to be doing for all. So if you want to find the marginal distribution for job grade, so we're going to take it for all the job grades overall. Well, the grade 1 total was 955. Sorry, go back so you can see that for a second. So here are your totals for the job grades overall. So you're going to do the overall total with marginal distributions. Okay, and you can fill in the rest of those percents. So about 12%, about 52%, and find grade 3 and 4. So percents are often more informative than counts, because you can see how it compares relative to everything else. All right, so just a summary of section 1.1. The distribution of categorical variables lists the categories and gives the count or percent of individuals that fall into each category. Pie charts and bar graphs display the distribution of categorical variables. A two-way table of counts organizes data about two categorical variables, and you need to know the difference between marginal and conditional distributions.